How are you, my friends? This is another pre-calculus challenging question where each graph is above the x-axis. I have here two functions. F of x is equal to 2 times log of x. The other function, g of x, is equal to log of x squared. Why I put two functions here? Because they are a little similar and there is a little difference in the argument. So for other pre-calculus challenging questions, you can see, please, the playlist down here. Now we have the two functions. Just by looking, it's very clear that these graphs are not the same because the arguments here are not the same, even though sometimes we can bring the two down and it becomes 2 times log of x. I will show you all the details. Let's start with the first function here, f. This function is logarithmic function. The base is 10. Here, we don't write it here. The base is 10. Greater than 1, it is an increasing function. And the 2 here outside, 2 is a vertical stretching of the graph. So we can start here to graph the function f by basic logarithmic function base 10. So this is the black one here, you see. Let's call it n of x. So this function will be n of x. This is the log of x. It is a dashed black graph. Now, this n here multiplied by 2, we will get f. So it will be a little vertical stretching and the same x-intercept. So the graph of f now is the red graph here. F is the red graph. We can answer the question where the graph of the f is above the x-axis. We can go from here. It's one open until infinity. Just an extra information here. If we need to find the domain of the whole function f, just take the argument. Take this argument, which is x greater than 0. So the domain will be from 0 open to infinity. Now the second function here, the g of x, this is the second function. We have to discuss it further. First of all, g of x will be log of x squared. This is not equal to 2 times log of x. Now, sometimes we say this is true. Let me explain the whole story. This is not true because of the power law. The power law says log of base a, or u to the power n, we can bring the n down on the line, times log base a of u. Now the conditions here, u, which is the argument here, should be greater than 0, a greater than 0, a not equal to 1, n is any real number. But here this is x squared. We don't know what is x. X can be positive, x can be negative, but x cannot be 0. Because we don't know if x is positive or negative, we cannot use the power law for this function. So what do? We can look at the argument here, x squared. So we can look at the domain of the function g, which will be all real numbers except the 0. So it will be negative part and union the positive part. Also, we can see that this function is an even function. We can replace here minus x in the function g, and then when we simplify it, we will get the function again, the same function. So g of minus x will be log of minus x all squared. This will be x squared, which is log of x squared as the function g. So g of minus x is equal g of x. That's an even function. Now we can graph the g. So we can graph log of x here where x is positive. And this is an even function, so it is symmetric about the y-axis. So there is a reflection here on the y. So both of these pieces, the blue one, this is the function g. Now we can answer the question. The graph of g, this is the graph of g, is above the x-axis on the interval minus infinity to minus 1, above the x, union 1 to infinity. See, it's different from the function f. And also the domain of g, as I mentioned before, minus infinity to 0, union 0, open to infinity, or real numbers except 0. Now, in this slide, we can see the two graphs together just to compare. See, this is the function f. Just quickly here, the argument here should be positive. So that's the graph, the red one. And here x squared. So x can be positive, can be negative, but not 0. So it will be two pieces there and above the x in each one. Now for more logarithmic functions, please, you can see the playlists, either pre-calculus, all the exams questions, logarithmic functions, or you can see the pre-calculus course lecture number 5. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I wish I can see you in another video with another pre-calculus challenging question. Thank you for listening, guys.